we have the task to present what is the thermal stratification and the quantification assumptions. We have one area sensitivity analysis depending on the transfer constant between the upper and the lower compartments and the lower upper, and also the depth of the lower of the warm water.
Okay.
Depth of the upper compartment.
Yeah. Okay, and after to propose a method to explain turnover of the model, since the thermal stratification occurred in spring, summer, and after it changed, so there is turnover of the system, and to explain how we can model this.
It's more broader than our model. It's very
You study the source of.
yeah, but we don't have the thermal stratification.
But you change the
simple
inputs.
one.
Yes.
We just took the results of the previous study for the input and changed it. It's really studying the outputs.
Well, vary the value of a different concentration with maybe 10%, 20%, 30%, or 60% and 80%. And then we do it. Then we run a model and get different value in different concentration. And this what we can see from the diagram that the concentration in the sediment has is almost doesn't change. It's almost it's a horizontal. It's a horizontal line. So the concentration in the sedimentation part has no effect, has no connection with the concentration, with the upper concentration and lower concentration, and the depth of the upper compartment. But
I choose this project because two of the professors at my department do a project with a company about how you can use urine to make the farmers don't use to buy this fertilizer from the industrial companies, because if you use urine as a fertilizer, you have all the nitrogen and the phosphorus and so in the urine, and it's much cheaper to use urine, so the farmers want to use it. But if you use urine, it's many drugs which we have taken when we are sick, and hormones and so in the urine, which going down in the soil, and if these drugs and hormones reach the groundwater,
mine, and this impoundment is containing quite high amounts of contaminating metals, copper, calcium, zinc, sulfate. That's not a metal, but still, iron and magnesium. And the tasks was to make a mass balance of the total annual flux of these metals and iron from the impoundment, and then estimate the weathering rate of the minerals in the impoundment. Yeah, and this was coming pure water into this one, bringing metals and contaminants out and bring it to the surrounding water system. That might be a environmental issue. This old tailings from the 50s and the 60s, this one was used, and still in 1980, when these numbers are, or this impoundment was investigated, it was quite high amounts of metals and toxics, as high as the outgoing water. Yeah. And yeah, that's much about it. And questions might be.
Government decided to vary
barrels of mustard gas in the ocean or in the soil. And the problem was that the barrel corroded and the mustard gas spreads in the environment and contaminating soil water. So the aim of the project was to study the decomposition of mustard gas to amine-mustard, thiodicglycol, which form thiodicglycol and thioxane. So we can see that the hazard of mustard gas was very toxic. It is irritant and it's very dangerous for the environment. So I just do, first of all, a differential mole balance, which give me this equation, and I use MATLAB software with the initial condition that Ca0 equals 0.8 gram per liter, and I have also the kinetic constant K1, K2, K3 as well. So I just put all my equation in my MATLAB file, and I managed to plot the curve of the concentration of each compound as a function of time. So we can see that mustard gas, which is compound A, decrease, the concentration decrease, and the concentration of amine-mustard first of all increase. Then after it give thiodicglycol and thioxane, so the concentration decrease and the concentration of C and D increase, until to reach at the end concentration of 0.65 gram per liter, and for thioxane the final concentration is 0.14. But it was not widened, so I can just say that it's still dangerous for the human because of if it is irritant, but for the environment it was not.
So how about the degradation of those C and D then? Or are they like persistent?
Yes.
And run the model similar with 5 different copper inflows, and then also to find out like which is the dominant process. And yeah, so if you see the model, yeah, you have the inflow with the copper, and you also have some
anthropogenic sources.
yeah, from anthropogenic sources, like and also like from the railways, rooftops, and from the vehicles parking. So you have, and that's how like the copper gets deposited in the lake. And if you see, this is Ma, that is the sediment of the active accumulations. That is, suppose the whole portion is a lake, so this sediment is 0 to 2 centimeters. And this one is the sediment of the erosions. So it is mobile, the sediment. And yeah, and then we had to run it with the inflows. And if you see, this was run within inflow of 5. And yeah, the steady state was, if you can see, like it's so gradually decreasing, and then it reaches steady state. But this one reaches steady state like with the concentration somewhere between like 70. And yeah, so we also found that when the inflow is somewhere between 21 and 23, like then the lake cannot absorb, and so the concentration starts increasing. So if you can know the difference. So, and when it comes to 30, then the concentration increases very high. And
yeah, in fact, it's also this is just from the sediment, like the sediment in the active bottom, the 0 to 2 centimeters. We have some different behavior for the water pillar, the concentration of copper in the water pillar, and then the erosion, the sediment from the erosion and transportation. Yeah, But we don't know if we focused right, because we were asked to evaluate five different random concentration of copper, and we wanted to focus this on where is the inflection of the curve, like what's the point that the water in the lake cannot absorb the copper anymore, and then the amount of copper in the sediment will become very high.